Dividing polynomials. The first example I want to do is when we're just dividing by a single term on the bottom. We call that a monomial sometimes when there's just one term. So dividing by a single term, you're going to just go through however many terms there are on the top and divide them one at a time. So first I'll divide that by what's on bottom, and then I'll divide the next term by what's on bottom. And as far as dividing the numbers go, I don't have a number down here, it's just a -1, but you would divide the number part by whatever number is on bottom. So a 6 divided by a -1 would just be -6. So I'm doing this first term divided by what's on bottom. I do the number part first, 6 divided by -1, and then I do the variable and exponent part. And when you divide, if you have the same variable, and you're dividing, you subtract the exponents. So 6 minus 3 gives me 3. So that's going to be z to the third. So that's the solution for dividing that first term by what's on bottom. And then I want to do the second term. So I have a minus 11z to the fourth. Again, the number part, a -11 divided by a -1. That's going to give me a positive 11. And then do the variable part. And you do subtraction. So z to the 4 minus 3 gives me 1. So it's just going to be z to the first power, and we just write z. So that's your final solution here. Before I do my next one, I do want to talk just a little bit about why we do this subtraction. If you look at z to the 6th over z to the third, what do these exponents mean? By definition, an exponent means repeated multiplication. So z to the 6th power means z times z times z times z times z times z, 6 times. The third power means z times z times z. You multiply z together 3 times. When you have a fraction, if you have the same factors being multiplied together on top and bottom, those cancel out, they reduce to 1. Essentially, they subtract away. So doing this, here's a little visualization of why the subtraction works. All that you're left with is 3 z's multiplied together, which is z to the third power. So 6 minus 3 gives you 3 z's left. And that's why the subtraction part, why that rule works for dividing. The next one here, the same scenario, we just have a single term on bottom, just a monomial. There's not multiple terms being added or subtracted together. So we're going to do that same rule. We just go one term at a time on top until we have divided each term. So the first term here, I look at the numbers first. A -16 divided by a -4, that would give me a +4. And then each variable can only be combined with that same exact type of variable. So I need to look at just the r's first. So r to the 6th and r to the 4th. I would subtract the exponents, and 6 minus 4 gives me r squared. And now just look at the s's. 5 minus 4 gives me 1. And so this is my first term here is 4r squared s. My next term, coming over here, a +20 divided by a -4 would give me -5. And then looking at the variables, 4 minus 4 for the r's would give me r to the 0. That reduces to 1. Essentially, I don't need to write anything because it's just equal to 1. And then same thing with the s's. The exponents here, 4 minus 4, reduces to s to the 0 power, which is just 1. And so 5 is my entire answer from dividing this second term on top by what we have on bottom. All right, last one here where I just have a single term on bottom. 45 divided by 15 will give me 3. And then looking at the variable, subtracting the exponents, x to the 8th and x to the 6th, that would leave me 8 minus 6 is 2. And then going on to the next term, I have a -15 divided by a +15. That's going to give me -1. And then x to the 12th power and x to the 6th, subtract those, and I would get x to the 6th. 12 minus 6 is 6. And I'm going to go ahead, we don't usually write the 1, so I'm just going to go ahead and erase it. 1 times x to the 6th, I would just write x to the 6th. This would be my final solution here after doing that division. Now look at some division problems where we're not dividing by just a single term. I have some addition or subtraction in what I'm dividing by. This is a binomial. There's two terms, x and minus 6. So how do we do that? We want to set it up, if you remember dividing long division with just numbers, we would set it up like this. You'd write your division bar and you would write what you're dividing by off there to the left. So we're going to do the same process that you might remember from when you were first learning about division, long division with numbers. The thought you need to have in to complete this is just looking at the x term here and thinking about what you need to multiply it by to get the first term that we are dividing into. So x times what would give you a 3x squared? So you can think about the number part and the variable part like we were before. This is just a 1x, so 1 times what is 3? It's going to be 3. And then x times what gives you x squared? So now, past the number part, now looking at the variable part, think about the exponents. I have a 1 here. How many more would I need to add on to that to get to x squared? I would need to add 1 more. So I would need x, I would need an x there. And you can kind of check your work. 3x times x, that would give me 3x squared. So like with long division, whatever you write up here that you're dividing by for your answer, you multiply it by both of the things. You multiply by everything out in front, which in this case is both of these terms. So 3x times x gives us 3x squared, and you should always have this be exactly identical to that first term if you've selected the right thing to go on top. So that gives me 3x squared, and this gives me, so the number parts, multiply those together, that is negative 18, and there's no x to be included here, so that's just the answer, negative 18x. So I'm going to write minus 18x. All right. What we do here is, just like with long division, we subtract. And this can be tricky because you have to pay close attention to your positive and negative signs here. The first term should always cancel out. If you've done this correct, 3x squared minus 3x squared is 0. That's what you should always get. Now really pay attention to our negatives. We have negative 16x minus negative 18x. So minus and a negative, that'd be like adding 18, which would give me a total of positive. So I'm going to just write plus positive 2x. And we're not done yet. There is another thing up here that we're subtracting. Negative 12 minus, well, there's no number term here. I could have wrote 0. And that it can be nice to write in those placeholders so you don't forget to do any of the subtractions. There's 3 subtractions here to do. I did the first one, I've done the second one. There is one more to do. Negative 12 minus 0 is going to still give me negative 12. Essentially, if you just don't forget about it, you're going to bring down that last number. Bring it down here. All right. Now I repeat what I did from the very beginning. But now, see this blue arrow? I kind of left it here. We were looking at this term. Now, I'm going to draw it here in red. You look at the first term that you have, just like we looked at the first term here. Our first term of what we have left is a 2x. So x times what gives me 2x? Think about the number parts. There's a 1 here. So 1 times what is 2? The answer is 2. So I want a 2. And then my variable is 1. How many would I have to add on to that to get to 1? Well, I'm already where I want to be. I don't need to include any more x's. So it would just be a 2 up here. This is my final answer. 2 times x gives me 2x. Great. Now that I have that, I need to multiply it by both terms out here and then do my subtraction. So 2 times x gives me, let me change my color up again, gives me 2x. And 2 times the minus 6 gives me minus 12. Okay, subtraction now. This first part should always subtract out to 0. 2x minus 2x gives me 0. And negative 12 minus a negative 12, that's also subtracted out to 0. So I have no remainder. This divided perfectly with no remainder, and this is the solution of that division. You could check your work. If you do 3x plus 2 and you multiply it by x minus 6, you get the result here. All right. So do the multiplying two polynomials together to check your work, and you should get right back to that polynomial that you just divided. I'm going to do one more here with division where we have a binomial, more than one term. We're going to write it out here as long division. And we have u plus 7 is what we're dividing by. Think about what you need to multiply the u term here, what you need to multiply it by to get that first term. So there's no number here that I'm trying to get to, so I don't really need to think about the numbers. Just looking at the variable term, it's u to the first power. How many u's would I need to add on to get to the third? It's going to be u squared. And then multiply that by both of those terms here. U squared times u gives me u to the third power, and u squared times 7 gives me 7u squared. Now, what's really interesting about this one is there's no u squared up here. So doing the subtraction, I really recommend filling in every single spot from your highest exponent all the way down to your lowest. So I'm going to go ahead here. There are 0 u squareds. We can all agree to that. So let's just write. Let's write that. There are 0 u squared plus 0 u squared. And that helps you keep everything lined up and not mess up with your subtraction. So there's 0 of them, minus 2u minus 6. Anytime you have a blank or something missing, if you're counting down by the exponents, this time it starts with 3, so I should see a 3, a 2, a 1, and then a term with no exponent. Make sure those terms are all showing up, and if one of them's not there, write in 0 for that term. Right, so doing the subtraction, this first part should always subtract away. And again, I'm going to go ahead and write 0 for both of these. So there's 4 things here. I should be subtracting away these 4 things. This first term cancels out. U to the third minus u to the third, that's 0. 0u squared minus 7u squared. So 0 minus 7 gives me negative 7u squared. Negative 2 minus 0, I still have negative 2, and negative 6 minus 0. Essentially, you just bring back down those extra terms at the end. All right, so I want to go ahead and erase this 0 in front, just so we don't worry about it. Here's what I have left now after that first step. I need to focus on the very first term and think about what does this term out here need to be multiplied by to equal that first term. The number in front of it is 1. 1 times what is a negative 7? Well, negative 7. The variable is an exponent of 1. How many would need to be added to that to get this new exponent? It would be 1. So u to the first power. Multiply that by both of these terms out here. Negative 7u times u gives me negative 7u squared. And negative 7u times 7 would be minus 49u. All right. So again, we need to subtract here. The first term should always subtract out. Go ahead and write my plus 0 so I see the 3 terms I'm subtracting from each other. These will reduce to 0. Minus 2u, let me write my subtraction sign here. Minus 2u minus a negative 49. That's going to give me a positive 47u. And negative 6 minus nothing, I just bring that down. It stays negative 6. All right, so as you get more proficient about this, you can stop writing your leading zero. You just know those cancel out. I keep erasing it because I like to focus on that very first term because that's what I'm always focused on the next step. So u times what gives me a positive 47? It would need to be, or sorry, the number 1u. 1 times what is a positive 47? It would be a positive 47. And for the u part, the exponents are both 1, and I don't need to multiply by any extra exponents here. I'm already set. So 47 times u gives me 47u. So I'm taking this 47 and multiplying by both parts down here. 47u. And 47 times 7, bust out a calculator, you're going to get 329. And we're doing subtraction. Now this first part should always subtract out to 0. Yeah, it is again the case here. And negative 6 minus 329, that's going to be negative 335. Okay. So there's no more division left to do. And how do you always know that when there's no more division left to do? You can tell by just looking at the variable part. This was a u to the first power, and we have less u's than that now. There's no u's at all. It's u to the 0 power. So once you get to that point where the first leading term out here, there's no u's to left in what you're dividing into, you're done with your division. So this is the result, but we have a remainder now. You can see this negative 335 is our remainder. We didn't get a nice perfect, like in the last example I did, we had all zeros, there was no remainder. So the way you want to write your remainder is you write it as a fraction. All right, so our answer, when we do this division problem, we get u squared minus 7u plus 47. That's what we already have. If you do this polynomial and divide it by that, oops, sorry. This polynomial and divide by u plus 7, you get this result with a remainder. And your remainder is minus 335 over whatever you're dividing by, u plus 7. And I'm going to wrap up the video by a really quick explanation about why we wrote the remainder like that. That's how we need to write it. If you think about dividing something, we divided this right here by our u plus 7, and we got a result. If you take that result and multiply it by what you divided by, you should end up with that original polynomial, that original value that you were dividing by. And sorry, this had a minus 6 on it. It got erased here. And so if I actually take my answer for my division, with that remainder written like that, that's what I have here, and multiply it by what I divided by, I am going to end up with that original polynomial. And so you can see that really quickly here. U squared multiplied by both things out there would give me a u to the 3rd, and then plus a 7u squared, minus 7u times u is minus 7u squared, and times 7 is minus 49u. 47 times u gives me a 47u. 47 times 7 is a 329. And in this term, times u plus 7 is just minus 335. The bottom part would cancel out with what's out there, and that is why we have to write it like this, so that that remainder part is going to reduce down to give us the result we want, that original polynomial. So canceling everything out here that combines together, the 7u's plus 7 minus 7 are gone. The u's here would be minus 2u, and then these two numbers, sorry, that should be a subtraction there. I don't know if you caught that mistake. But minus 335 multiplied by that, it should be minus 335 there. And so what we get then is a minus 6. And that's our original polynomial.